Yep. All right. So I think that I will get started. I have a long presentation covering some topics that are extremely long. And this session is called Spring Cloud, Docker, and Kubernetes, and all the lessons learned in the context of an open source project. But as the title is suggesting, there is some kind of a sequence, right? And of course, before Spring Cloud is a Spring Boot. So I would like to make this presentation as interactive as possible, because all these topics, again, is like going through a journey of understanding each of these ones in order to deploy something into Kubernetes. And even if Kubernetes is at the end, you know, in this title, there are tons of things coming on top of Kubernetes as well. And I don't want to overwhelm you with tons of things, but this presentation is more about giving you pointers if you're analyzing these technologies. So important, really important for me, how many people here is using Spring Boot? Okay, so it's not tied to Spring Boot, but because I'm talking about Spring Cloud, it's important for me to understand. So let's get started with this. So my name is Mauricio Salatino. I do work for a company that is called Alfresco. The company does content management and business automation tools, and I'm currently in charge of an open source project called Activiti Cloud. How many of you guys have heard about Activiti, the Java framework? Okay, I have one Activiti user there, more Activiti users there, that's great. So I'm now in charge of this open source project, and we are moving away from what Activiti was before, that it was just a Java framework and a web application, to a cloud-native set of building blocks. And this presentation is not about Activiti Cloud, but it's about the technology stack that we are using to build this framework. And again, this is just one example of cloud-native stuff that is using this technology stack. So I wanted to share a little bit about what Activiti Cloud is and how it looks like from the architectural point of view, to give some kind of like background and a scope about this presentation in general, about what kind of applications or what kind of things are we building that are pushing us to think about these technologies, right? Activiti Cloud, as you can see, is based on Spring Cloud, Docker, and Kubernetes. That means that when we designed these things, we thought about deploying into Kubernetes as our main deployment platform. How many of you guys are looking into Kubernetes? That's quite good. It's like a third, I would say. So that's pretty good. So Activiti Cloud, when you see it from very, very high level, is a set of two main things. One is infrastructure, which is the big box that contains a gateway, and it will contain a set of platform services that you're going to use. And then Activiti Cloud applications, right? Activiti Cloud applications are just not Spring Boot applications. They are a bunch of things. So each of these blocks is a container at the end of the day. So you can imagine that if you want to deploy an application that it's 10 or more containers, then you are going to have a hell in understanding how to do that, understanding all the technology and how the pieces will interact between each other. So this presentation is mostly about how do you build these kind of things. And things tend to go really, really complex, and that takes time. If you don't want to look into Activiti Cloud, you will see that some other communities, like, for example, the JHipster community, it's building applications in a similar way, right? So how many of you guys have seen or heard about JHipster before? That's, yeah, I would say 20%. That's good. So if you are looking into these kind of things, you will see some common cloud-native patterns appearing, right? So when we talk about cloud-native in general, we will talk about these components, like, for example, a gateway that I mentioned before in Activiti Cloud. Here in JHipster, you can see there as well. You will think about having a service registry, which is Eureka in this picture, and a configuration server to configure all the things that you are building. And at the bottom, you see all the monitoring capabilities and tracing capabilities for the platform, because now you will have tons of containers doing different things, tons of little services doing a lot of things, so you need to know what's going on there, gathering metrics and understanding how things works. Another important feature here that also was in Activiti Cloud is this concept of security. If you have multiple services, you will definitely need to provide single sign-on for your services, right? And that's kind of like a given if you are building multiple services. And in the middle, then you will put your domain logic, your own microservices. So similar thing, this tends to go complex, right? So this presentation is all about how do we get there. So I started Activiti Cloud a year and a half ago, and we designed it, we planned it, we made that decision of saying we are going full on Kubernetes. So we don't really care about any other deployment infrastructure that is not Kubernetes based. And that's a big decision. And what we knew at that time is that when you are building stuff for Kubernetes, you need to design for it. It's not that you design whatever. You cannot grab your web application, put it in Docker, and then deploy it into Kubernetes. You can, of course, do that, but that's going to work until a certain point. You need to design in a cloud-native way. So this journey, that band from the 70s, American band from the 70s, if you go to Wikipedia, you will find that it's one of the most beloved and one of the most hated bands from the 70s. So the journey is pretty much like that. It's like, I love it, I've learned a lot of things, but it gets complex quite fast. Quick disclaimer, we started doing this because we have a strong knowledge about the domain that we were working on. So that means that we had a monolith that we clearly understood. It was quite big. It has tons and tons of features in there. All the features in different like maturity levels. That was complicated to maintain. So we decided to say, okay, these are like the 100 features or the 1,000 features that we have. We will take a 10% or 20% of those that we know that our community users and our customers are using, and we are going to start creating microservices for these blocks. And that's what basically Activiti Cloud is. So totally recommended not to start from a microservice approach first if you don't know what the system as an entirety is. So, of course, we started with Spring Boot. That's the most natural thing, and I can see that people know about the Spring Boot. And when you know about the Spring Boot is not the problem, right? It gives you all the ingredients that you need in order to build your service. You have all the tools in there to create the microservice quite fast, based on conventions, great stuff. The problem is all the other things that you have around a Spring Boot, right? So you might have a database, you have a message broker, and then you start asking the questions of, okay, if I have a team of developers, I don't want to install a database in each developer's laptop. I don't want to have a centralized database that everybody needs to connect to it. So you start thinking about Docker and Docker Compose for enabling developers to work in environments that can be easily reproduced. So we start playing with Docker Compose and said, okay, if you have a database, message broker, single sign-on or whatever, you have a Docker Compose file, you can start it, and you can start coding your service against these services that are close to you. How many of you guys are using Docker Compose? Okay, that's a quite large number. That's very, very good. When you start looking into what a Spring Boot application will be, in general, you can do a lot of crazy things with a Spring Boot. It's flexible, but at the same time, it's very aligned with the idea of a Java application that will run inside a container. So we definitely looked at 12factors.net. How many of you guys knows about the 12-factor app concepts? Okay. You definitely need to check it out, guys, because that basically gives you the principles on how your application should behave, how each of your services should behave if it's running in a container. If you don't follow this 12-factor approach, then you are going to put something in Docker that wasn't designed to run inside a container, and you will start facing problems, right? When you go to Kubernetes, that explodes even like it's terrible. So we worked with this, and at some point we said, okay, when we look at it into one Spring Boot application, that's good. Let's think about a little bit about how do we handle the code. We were coming from this Activiti project. We have a single repository, tons of Maven modules in there, tons of features. The release process was extremely complex. If you want to release something, you need to release everything. That was not that good. So the example that I'm demonstrating at the end of this presentation, if I have enough time, is following this approach, and we are following this approach in Activiti Cloud. One service, one repository. This allows us to move extremely faster. And when you start doing CI/CD, this becomes really important. How many of you guys are following one service, one repository? Okay, this, again, it's related to 12 factors. It's really important. You scope all the code for that service in a single repository that you can release and isolate from all the other services. This is what I will be showing a little bit later. Then, if you have services, and again, if you are thinking about containerizing this into Docker, you will have a Docker file, of course, in that repository, right? So you have one service, one repository, one Docker file that basically allows you to create a container for that service that then you can share and then you can run. When you start playing with Docker, the next thing that you will realize as a developer is that you need to store the images somewhere if you want to share them with some other teams or with some other developers. So we started using Docker Hub in order to publish our Docker images because we are an open source project. You will need to pay if you want to store like in private repositories, or you can choose any other repository that you want to use for that. The tricky thing is, as if you are a developer trying to push for these technologies, then you will need to fight in your company to have a Docker registry available for your things. And that usually takes time, so you need to plan in advance for that. These kind of things, from the developer point of view, is the last things that you want to fight for, right? Like, okay, company, we are now generating Docker images. That means that you need to provide a Docker registry. You need to fight for that. You need to get it at some point or another. The other problem is that you start releasing Docker images, so you need to have a clear, defined process on how you tag the images, how do you release them, when do you tag them, how that is associated to the jars that you're producing for the Spring Boot layer, and all that stuff. When you are working in a single service, that's good because we all know Spring Boot. The problem is when you step back a little bit and think, okay, I will have 10 services, I will have 20 services. That becomes way much more complicated. And that's when these books definitely helps you to just answer some of the questions. Of course, you can read about them, but until you don't use the technology and you don't follow these approaches, you are not going to put that into practice, meaning that you know kind of like half of the things that you need to know. So totally recommend these 3 books. Definitely need to read them. It's something, if you are looking into these technologies, this will give you and your team like a quick head start on changing your mindset in how to build these applications. The first one, it's more conceptual. It's more about patterns, how to implement stuff. The second one is very practical on Spring Boot and Spring Cloud. I will touch on Spring Cloud later on. The second one is focused on Cloud Foundry, which is the pivotal software in order to do deployments, cloud-native deployments, which is not Kubernetes. So there is a gap there between what Spring Cloud is and Kubernetes. And we will go deeper into that. And the last one, domain-driven designs, there has been several talks about this during this conference, so I will not go deeper into that, but that's more on the organizational side of things. How do you organize your services? How do you decide what the boundaries are and all these things? So Spring Cloud, this is the most interesting part from my side in general, because I've been going through Java conferences, and when I ask people, how many of you guys know Spring Cloud? Hands up. Okay, good. That's quite a good number. In general, what people know about Spring Cloud is one of these things. So if you go to the Spring Cloud website, you will see that they have like different modules, and my feeling, at least when I ask this question, is that you probably know what Eureka is, or which is service discovery, or you probably know what the config server is, or what the gateway is. But Spring Cloud is a cohesive set of things, and in my opinion, it's just a set of abstraction layers promoting cloud-native patterns, right? So think about that like a set of interfaces that are abstracting you from different implementations on how to do things that you will need to do if you are serious about building distributed systems. So again, think about this as interfaces. And I will be demonstrating discovery, streams, and gateway later. Discovery, config, and gateway later on. We went through this phase after building our services, putting every service in each repository, building them, releasing them into Docker images. We went through this phase of saying, well, okay, so we can clearly create a Docker Compose file to start all these services, right? So if we have a front-end team that wants to start coding against these services, we can just give them a Docker file, they can start it, and they can start using it. So it was kind of good for some time, but we quickly realized that if we are targeting Kubernetes, that's not even close to provide the feature set that you're expecting from a distributed application, right? Docker Compose, you will have one instance of each service. If a service goes down, nothing happens. You just need to boot it up again manually. That's not what we're expecting, right? That's not the main idea behind creating these type of applications. So we then went through this phase of, okay, I've been working with Kubernetes for the last 3.5 years, and I knew that my team will, take some time to digest the concepts in Kubernetes, right? And during this journey, it's becoming clearer and clearer, like that we as Java developers cannot think about Kubernetes as something that DevOps will take, and we will just give them Java applications, and those Java applications will be deployed. We need to know how it works. We need to design for it. And that's quite a hard lesson, because that means that you will need to spend time with your teams in order to teach them how to use this and how to apply these concepts on the architectural side. And what are the things that you can use from the platform, right? We are going through this phase in the industry where most of our applications are focused on the business value that we can provide. And the rest is delegated to the infrastructure. So the more that we use the infrastructure, the better that our application is, the faster that we can build business value for that. There are several concepts related in Kubernetes. These are kind of like one of the most important ones. So what a deployment is, how do you deploy the applications into Kubernetes, replica sets, how many replicas do you have for your service if you want to achieve like high availability, service, load balancing between these containers that you're creating, and then configurations, secrets, cron jobs, and recurring tasks. So the most natural thing to do for a Java developer is saying, okay, how can I run this on my local computer? And that's kind of like a good thought. And if you want to play out with the concepts, that's good. So you have Minikube, and there is another one that is called MicroK8s for Linux, I think, that basically allows you to run a single node Kubernetes cluster in your local machine. Again, that was a phase in our journey. I will just recommend not to go through that phase, because at the end of the day, you realize that you're running a single node cluster. Again, that's not what you expect to run in production, of course. And so you're testing against something that is similar to what production is, but not quite close to it. So my recommendation is usually learn the concepts, try to apply them into an example, but then just jump to a fully fledged Kubernetes cluster. Because nowadays, it's very easy to get access to a Kubernetes cluster. And we as developers, we need to get used to work with these kind of things. Kubernetes, there is a blog post out there, and this is a common thinking when you use it. It's becoming definitely kind of like what an application server was before, right? It's dealing with clustering our services, we are deploying to it, and we need to design for it. So that's the key takeaway, I think. So we went through that phase of starting deploying into Minikube, testing, creating YAML files for it, and it was kind of working. But the problem is that when you think about the Spring Cloud, it was designed for Cloud Foundry way before that Kubernetes was popular. So there are some impedance mismatching there, right, that you need to be aware of. And we start saying, okay, in Spring Cloud you have these components, and there are some recommended implementations. But when you look into Kubernetes, Kubernetes is already providing some services that are kind of like duplicated. So you need to start thinking about it. We went through this journey. We said, okay, in Spring Cloud, when you look at what people is doing, is probably using Eureka or Consul to do service registry. In Kubernetes, you have a service registry already there. Every time that you deploy a service, you have automatically a DNS entry for that. So you don't kind of need to deploy Eureka into Kubernetes, for example. The same for configuration server. You have the concept of a config map inside Kubernetes. So you probably don't want to have a configuration server inside Kubernetes. And then the bottom line is more not on purely vanilla Kubernetes, but if you're going to do a cloud deployment, like when you are deploying stuff to AWS, for example, the last thing that you want to do is to deploy a PostgreSQL manually in there and maintain that instance. What would you expect is that AWS is going to provide you an instance of a database that is distributed and it's managed by the platform, not by yourself, because you will spend a lot of time tuning that database and configuring that. So the bottom line is it's not like that you can remove it completely, but if you are going to a cloud provider, you probably want to think about how to bind to the services that are being provided there instead of managing your own. Luckily for us, and we got involved quite heavily on this project that it's called Spring Cloud Kubernetes, which is bridging the gap between two worlds, right? As I mentioned before, Spring Cloud is just a set of abstractions. So this Spring Cloud Kubernetes project is providing the implementations for those abstractions to consume services from Kubernetes inside. So we get very close to this project. This project was in incubation process when we started, and we helped that project to move out of the incubation, and we are quite heavily using it inside Activiti Cloud. And the experience so far has been great because the interaction with the Spring community is quite nice. They are also catching up on Kubernetes, meaning that they want to learn, and they are quite keen to support all these things and to include, for example, Spring Cloud Kubernetes in the Spring Cloud release train. So that's kind of good. Another takeaway from this presentation, if you are looking into Kubernetes, definitely take a look at this project, right? Then it's like YAML hell, right? So if the moment that you start looking at Minikube or you start looking at deploying into Kubernetes, you realize that for everything that you need to do against Kubernetes, you will need to create a YAML file that basically creates a resource into Kubernetes in order to do deployments, in order to create services and abstractions. How many of you are writing these YAML files? Okay, we have a couple of Kubernetes users here that are writing these YAML files, which is great. So we went through this phase where we start writing YAML files for every service. We needed to maintain those. We need to keep track of them. So if we wanted to have consistency between different services with the descriptors, we need to do that by hand. That was not scalable. It takes time. When you have 10 repositories, you can do it. It takes a lot of time, but you can do it. If you have 20, 30 repositories, it becomes unmanageable. And then we went through learning HELM. How many of you guys are looking into HELM? So this is another key takeaway, right? So if you're looking into Kubernetes, you definitely need to look into HELM. It's a must kind of like use. For me, at least in my experience, it's like, yeah, this definitely makes sense. If you don't use HELM, then you're going to try to solve the same problems that HELM is solving, on your own, and that takes hell of a lot of time. But again, it's like one more thing that you need to learn, that your team needs to learn, and things that you want to, plan ahead for. And then it's kind of like choose your destiny. It's like, okay, what's the best evil that you can choose? Well, you can go to any of them, or you can use your own. if you want to maintain your own Kubernetes, which I've heard people is doing it, right? Like, for example, deploying Kubernetes using kops into AWS, that's fine. You need to maintain that, and good luck. You need to have well-trained people to do that. If you want to install the Kubernetes cluster on-premise, then again, good luck. As a Java developer, I don't even want to know where my Kubernetes cluster is running. So it really depends on your company and what are your plans and your business alignments, right? And then you can choose any of them. In general, they will all behave similarly, but they will all have their own little things that you need to be aware of, right? Different concepts, maybe different resources, maybe different ways of building stuff in there that you need to be aware. And again, I totally recommend just to pick one and try to go with it. This is personal advice. I had a great experience with GKE, which is the Google Cloud Platform, and the demo that I will show today, it's running there. The only reason why I say that that's good, because you can just go and create a cluster, and that it will work, basically. I've been trying EKS, and I've been, of course, OpenShift, and I've been trying Azure and PKS. The last one is the one from Pivotal, the Spring, company, the company behind Spring. And those are quite good. Some of them, like OpenShift and PKS, I'm not sure if Azure has the same thing. You can run them on premise. Correct me if I'm wrong, OpenShift guys, but that's a good idea. So there are tons of situations where you said, okay, we have customers that they don't want to go to the public cloud, right? But by choosing Kubernetes, you are covering all these possibilities. So that's, for me as a Java engineer, it's a good investment of my time. I know that I work now for a company that likes, let's say that they like AWS, right? But if I want to move to a different company tomorrow, I know that no matter which cluster, which cloud provider they're using, I can, keep doing the same thing. And then for us, it was quite late in the journey, but get ready for CI/CD pipelines, because if you don't automate all this stuff, then you go crazy. So get ready for CI/CD pipelines, and when I say CI/CD needs to be seriously implemented and correctly implemented. It's not like, oh, we are doing half CI/CD. No, it needs to be seriously done. I'm telling this mostly because we have, again, like 25, well, more than 40, so 25 framework repositories and then some 20 service repositories. And for a team of 4 people, that's quite hard to maintain and deal with. So we started the automation a couple of months ago, like fully automating all this stuff, and that's going great. And I now can clearly sleep well at night. That wasn't the case for the last year. So when we were working on trying to do all this automation, we started communicating and contributing with this project, which is called Jenkins X. The first natural feeling is saying, oh, this is Jenkins in the cloud or something, whatever. It's kind of not like that, right? So you need to definitely clearly look at this in deeper detail, right? Why we start using this? Mostly because these guys are definitely experts on the field. They have been working with Kubernetes since day one, so they kind of know the industry. They are picking the best of breeds of conventions that are coming from the Kubernetes community, which is a polyglot community. It's not only Java, which is good. That's good, because learning lessons for other communities as well and putting together things based on conventions it's always good, right? So what we wanted to avoid is to define our own ways to create Helm charts or our own ways to create Kubernetes descriptors or Docker files. We didn't want to invent any of that. None of that is part of our core business differentiation, right? We wanted to build services for business automation or whatever that you're building. So none of this is our concern, and we know ourselves. We are developers, so we like to invent new stuff. The moment that you invent something for your use case, then the moment is that you need to maintain that later on. We didn't want to maintain all these things. So Jenkins X allows you to basically work on a convention-based approach using all these tools that I've been mentioning before. And because we were using the tools, these tools feel quite naturally to us. Like, yeah, great. We can use it because we were creating the descriptors in this way. We were creating Helm charts anyway, so let's allow the tool to create these things for us. So Jenkins X is basically a set of things that are installed into a Kubernetes cluster that allows you to go from nothing to having CI/CD and deploy stuff into Kubernetes, which is quite awesome in general. And it uses this idea of GitOps approach. How many of you have heard about GitOps? Okay, a few of you guys. This is, again, another key takeaway here. The idea is that if you have like a development environment or a staging environment or a production environment, you can deal and work with that environment using a Git repository, right? So the configuration for each of these environments is stored in a Git repository, and the way that you deal with promotions between different environments is by sending a commit or a pull request to the repository. So you send a commit or a pull request to the production environment. That means that you are trying to promote the service from staging or development or testing or whatever into that environment, and that pull request can be reviewed and automatically like tested before merging into production, which is kind of great. And then also, of course, you have automatic and manual promotion, right? So you can automatically develop to like deploy to testing environment and then manually say, okay, this is ready to go to promotion. You can do that. Getting started with Jenkins X is quite easy. It's like extremely fast. And again, I have nothing to do with the team besides collaborating with them, but I think that they are doing a great job. And if you are starting with Kubernetes, that can definitely reduce the journey that you're going to go through. So in Mac, you just install the CLI tool. Then you basically need to have a cluster where you want to install these things. And JX install is going to basically deploy Jenkins X into your cluster. And then basically you go to your Spring Boot application, and then you just import it. And you have a Spring Boot service, nothing else, and it will take that Spring Boot service, go through all this journey that I've just described, and you will have a service up and running in a Kubernetes cluster. How powerful is that? That for people that is looking into this, that sounds like magic. Of course, this is no magic, and they are using tons of tools, so I will be doing a demo trying to demonstrate that. Everything can go wrong. But at the same time, it's magic, but you need to understand what's going on because you, as a developer, need to know every step and know how to troubleshoot those things. So I will try to do a demonstration, but as I mentioned before, everything can go wrong, completely wrong. But the main idea is that, again, give you some pointers of the things that you should be looking into if you are trying to do this kind of stuff. So the scenario is about, a website trying to sell concert tickets, like for events. So you can create concerts, and then you can associate tickets to that concerts, to those concerts. And the architecture will look something like this. So again, the idea of having a gateway. If you have tons of services, you have a single entry point for your consumers to go and access to all the services. We have a concert service, which is a container, of course. It's a Spring Boot application that contains the list of the services. It's not here in the diagram, but I'm using MongoDB and the reactive drivers in order to create, reactive endpoints for that. I will not demonstrate that, but that's there. MongoDB is running somewhere there. And then I will create these other ticket services, right? So each concert will have an associated ticket service that will decorate the concert information with the available tickets, right? The idea is to simulate that at some point, you want to delegate the selling of the tickets to these services instead of going through the concert service. The ones we had like the check is the ones that are already deployed in my cluster, but for all of them, I use the same procedure that I will be demonstrating here, right? And of course, the concert service and the ticket service and even the gateway are going to use the Kubernetes native services for doing service discovery and configuration, right? I know that that's a lot. But the idea is that you can take this. Everything is open source. It's in GitHub. You can run it. And we wrote some kind of tutorial. It's not complete, but you should be able to get it up and running, right? I want to close the gap between thinking that you want to use Kubernetes and going and using it, right? So I've been doing some workshops around that where people is like phased to use it, and then you feel much more comfortable after using it. Because when you think about this is a quite complex beast, but when you use it, and when you say service is up and running, then the perception is a little bit different. So what I wanted to do here, it's a little bit of live coding. I am terrible at that. But okay, again, in GitHub, you can find this docs repository, S1P docs, which basically shows the scenario, describe what's going on, and have pointers to the most important size of the code, right? That's what I will be trying to show now. The first thing that I will do, I will go to Spring Initializer, which is basically going to create me a Spring Boot app, right? And it was quite funny. I went to Spring One platform 3 weeks ago, and Microsoft was announcing that they are going to provide a pull request. So you can click here a button, and it will create the project into GitHub, which is kind of like a good thing to have. But now you need to select your dependencies, right? I'm selecting the web component, the actuator component, because I want to monitor my application. Security, because I need some kind of like security filtering there. And also a Spring Boot admin that allows me, again, to put a dashboard on top and see all my Spring Boot applications in a single place. So I'm creating a ticket service now for a tango band. I'm from Argentina, so I'm supposed to dance tango, but no way. That's not going to happen, guys. So I can live code a little bit. So let's download this project first. And we have that. I want to show that I'm not cheating. If somebody see me doing something that they don't understand, please raise your hand. But I just want to do the entire process and see if I can get it working, right? So I have a zip file with a Spring Boot thing in there. I've just copied to a different directory, and the next thing that I will do is I will try to open that project here. I want to do this now that I have 20 minutes left, because I will run this project through this pipeline to have it working on top of inside of Kubernetes, and that takes time, right? So this is the guy that I created before. And this is just a plain Spring Boot application. There is nothing weird here, and IntelliJ will take its time to load it. And you can see same dependencies that I've selected before. I'm not hiding anything in there. And then the basic stuff that it's generating, but the initializer, which is the application class, right? So I have the application class in there. So instead of live coding some of the stuff, I have some templating for that code that I don't want to write, and I will never remember how it looks like. I need to just do the imports. That's security. Sorry if you don't see that. Let me put it bigger. So that's nothing, security configurations, just making sure that I can access some of the endpoints. And then I will do a basic, REST controller. Yeah, I was planning to do with web flags, but that takes more time. So get mapping. This is creating an endpoints. It's called tickets. I need to make sure that I don't make mistakes. If not, so this is basically just return the amount of tickets available for that specific concert that I want to create. I will say that for Tango, I don't know how much people can go there, so let's put 100 people. It's a small concert. So that's basically my application, right? And the main point here is just to show that I can quickly create an application and take it through the pipeline. Of course, like hello world kind of things are usually not that useless. So later on, we will take a look at the concert service, which has a little bit of more meat that I cannot live code quickly here. The other thing that I need to do here is just add some extra information here in the Spring Boot plugin, right? Which is just to add information, so when I want to show the application into the dashboard, it has the version and it has some other metadata there. Nothing extremely important there. And the last thing that I need to add is I need to go to the application properties file and add some more actuator kind of things that I need to enable, right? So I want to see the health of the application and some information, and I need to expose those things, right? I just need to make sure that I have access to these endpoints when I start the application. So it is not important. This step is completely just for me to check that the application is starting up at least. So I will just do a clean install. Oh, sorry if you cannot see that font. It's small, but it's just compiling and it's just running the basic test that it's created in there, which basically boot up the Spring Boot context, and that's basically okay. I didn't need to do that in order to run this in Kubernetes, but I will just do it. So now the interesting part, right? Like the important part. So I have installed Jenkins X and I configured it against the cluster. As I mentioned before, this is running inside of the Google Kubernetes engine. And I have that cluster called Spring Cloud Kubernetes there, right? And it's in Europe West. It has 3 nodes and 6 CPUs, which is kind of like a lot, and then 22 gigs of RAM. So that it's there. And what I did before, as I mentioned, is I installed Jenkins X in there. So I installed the CLI tool that it's in my cluster, like in my laptop, that I can use to communicate with that, right? And Jenkins X provides this concept of environments again. So when you are creating applications, you are in the dev environment. I don't know if you can see that guys. So you are in the dev environment. You can switch to the staging environment or the production environment. By default, those are the environments that are created automatically when you install the thing, but you can customize that and create QA environments or whatever other environments you want. So I'm on the dev environment. That means that I can go to my project that I just created. Right? So I can go to my project, which should be here. And it's ticket service Tango Band, right? So I'm there. You can see there is nothing different from any other Maven project in there, like any other Spring Boot project, Maven project. So what I will do now is I will import this project into Jenkins X. This is going to generate a bunch of things, the things that I mentioned before. It's going to generate a Docker file. It's going to generate a pipeline that knows that it's a Spring Boot application, so it knows through which stages it should go. And the stages, like summing up, is building a Maven project, creating a Docker image based on the Docker file that it's going to automatically create, Deploy, so deploy all those things, right? So if you create a jar file for your Maven application, it will deploy it to Nexus, that is installed there in Jenkins X. It will build a Docker image and deploy it to a Docker registry that you can configure. You can use Docker Hub or whatever Docker registry you want to use. The next step is going to build and package the Helm charts that it's also going to automatically generate for your application, and it's going to deploy that thing. And as soon as you have a Helm chart, that means that you can install your service into an environment in Kubernetes. So that's the next thing, which is the promotion step. So if I do that, I will import it, and it will ask me, first of all, it will ask, because I have the project locally in my laptop, right? It will ask me my GitHub user, in this case, or Bitbucket, or whatever you want to use. It will ask you the user because it needs to have this source code in a version control system. So that means that it will create a repository in my GitHub account where it will store the source code, and it will also register some Git hooks into there so it can monitor the changes for that source code. So I didn't have that ticket service Tango band repository in my GitHub before. Now it's going to create it. It's going to do the initial commit, right? And it's going to generate all these other files that I mentioned before. A pipeline file, it's going to generate a Docker file, it's going to generate some Kubernetes descriptors and some Helm chart descriptors. I'm running everything remotely, so as you can see, it's creating something in GitHub. This usually doesn't take much time, but it's a full room. Yes? Yep, I will show that. It's creating the repository. It's taking time for the Wi-Fi, I guess, so we can take a look at that. Yep. So now it's doing that again. So it will probably show up here at some point. So it should show up here at some point. We can also check here. This is Jenkins. I don't like the UI, but that's a different concern. They have a new UI as well, and they are changing a little bit how it looks and how it works internally. So when they, so that's why it's asking me for the repository name. So now it's going to create the repository name. It was creating all the files locally first. Usually this takes like 2 seconds when you have like a normal connection, but yeah. Now it's pushed. So we will see 2 things. Before showing you the repository, I want to go and show you that there is now a new pipeline registered here. And that pipeline, again, is monitoring that repository. I want to stop the build because before it goes through the entire pipeline, I want to do some tweaks in there. That's kind of like normal, right? So sometimes you need some specific configuration for your stuff, and you can change those. So if I go back to my repositories, showing the Git repository, that's an important thing. That's it. And the repository looks like any other Spring Boot repository, plus some other things, right? So we have the same POM file, nothing was changed in there. And now we have these other things that I mentioned. So we have a Jenkins file. I can show you that in the IDE, probably it's better. So the Jenkins file is the pipeline that contains all the stages. It will have a Docker file, which is quite simple. It's generated by default and based on conventions, and then the charts directory that contains all these YAML files that you probably don't want to write. So if you go there, there is a chart with your service name and then some templates for how to deploy this inside Kubernetes, right? And if you open this is using Helm templates. So you will see a lot of variables here. All these are variables, parameters that you can change based on your environment, right? So you can create a values file that basically will override or set the parameters for this deployment. The main idea with Helm is that you have a single Helm chart that it's, you can send parameters to it, so you can deploy the same Helm chart in different environments with different configurations in a very simple way and generate releases for these and then upgrade those releases based on your service updates. So the repository doesn't have anything in it, like anything weird besides that, and all these files are going to be used by Jenkins in order to build this service, right? So again, I didn't have that before when I imported the project. Now I have all these things. So before moving forward, the thing that I wanted to change in this new thing that was generated is, I need to remember what it is. First of all, I want to change something here in the service descriptor, right? So this is the service descriptor. Again, it's full of variables. I can show you that. It's full of variables, and if you are creating these descriptors already, you can understand what this is. It's basically saying, okay, I need a service to abstract where my containers are running, so if one container goes down, it doesn't really matter for the one consuming it. Kubernetes will create another instance, and you can still access through this service abstraction. This is very difficult to read here, but I'm going into the metadata labels, and labels in Kubernetes are used to correlate or to filter things and resources. So you can say, give me all the resources. I don't really matter if it's a container or a service abstraction that contain a certain label. And I will use that in order to filter the services in different places of the application. So I will just copy a set of tags here, labels, that basically are going to help me with that. So as you can see, this is very domain specific depending on what you're trying to do and where you're trying to filter the services. But as you can see, I'm creating a new ticket service for this specific concert that is for Tango Band, and I want to make sure that at some point the concert service can look for this Tango Band ticket service, and it can find it. And this is the way that I'm linking things, and this is the way that you usually discover things inside Kubernetes. So I'm doing that change, and the other change that I need to do is a little bit of tweaking on CPU and memory allowance, so the application can start, fast enough for the 9 minutes that I have left. So you change that again. As I mentioned before, HELM allows you to parameterize stuff. And this is basically the file where you can just change the parameters for how your application will work. If you're using Kubernetes, you will see that you have this kind of like readiness and liveness props that basically what they do is that they need an endpoint where they can go to the application to see if the application is alive or not. And if the application is not alive, they will kill that instance of the application and recreate another one. So I'm changing that, and that's pretty much it, what I need to do. It really depends on your application, how much you need to tune this. I totally recommend to stick with conventions as much as you can and tweak it as little as possible so the maintenance burden is not on your own. So I will just add this to Git, commit, update template, labels, and CPU allowance, right? So what happens, because I'm pushing this, there are Git hooks looking into my source code repository. The pipeline here is going to be triggered again automatically. I don't need to do anything. And now, when I was talking before about CI/CD and doing CI/CD seriously, this is all about what's going to happen now. I'm coming from a Spring Boot application that, of course, it doesn't, by itself, it doesn't have any CI/CD built in, besides the fact that you can create a new jar, and that's basically including your new changes. But what this pipeline is going to do is going to do a lot of interesting stuff. So basically, for every commit or for every pull request that we put in this repository, it's going to generate a new release for this service. And for all the artifacts related to this service, that means jars, the jar that is having the service, also the HELM templates, the HELM charts, and also the Docker images. So it will go across all these things and tag and label all these things with the same release numbers. So you can just go and use the release in your production or testing environment. So this pipeline is going to run for some time. It usually takes the first time like 6 minutes, which is kind of like okay considering of the things that it's doing. But the Jenkins X team is working to improve these times kind of like a lot, because if you think about this, you cannot wait for every change that you made 6 minutes in order to go through all this pipeline. There are tons of improvements and that can be done in order to reduce this time. As you can see here, Maven is going to download all the things and build all the things all the time. So going back a little bit more on what Jenkins X is, we can do something like get URLs, so you can see what's installed in there. And as I mentioned before, we will have Nexus if we are building Java applications and we want to deploy artifacts and release artifacts. We need that. You can, of course, configure it to use any other instance of Nexus that you might have in your company already. It will have Jenkins, of course, the one that we are looking at there. And it will have a Docker registry internally. But again, as I mentioned before, you can configure it to use, for example, I can configure it to use the Kubernetes, the Docker registry that they provide. The Google Docker registry that it's already provided in there. I didn't do that. And then Chart Museum to store the HELM charts and to maintain the HELM chart releases. So in theory, when the pipeline run, I should be able to come here in Nexus and say, okay, my new jar was released and it's there. I should be able to go to the Docker registry and see that there is a new Docker image released. And I should be able to come here, which is showing me all the HELM charts that I already have registered in here for this new service, right? So this is the other ticket service that it's already deployed, and it's in version 29. That means that anyone that wants to deploy this in any other environment can go and pick that up from this repository. That's quite powerful. And I know, again, that this is kind of like a lot, but all those things are happening. If you are going to use Kubernetes, you need to know all the details in every stage, and that's a learning process. So going back a little bit on the coding side, we can take a look at what's already deployed there. Like, so we have, again, the Spring Cloud Gateway. Spring Cloud Gateway was completely redesigned. You had Edgeware, Spring Cloud Edgeware before, which was using Zool and abstracting Zool with some abstractions there in order to deploy that as a gateway. Now Spring Cloud Gateway, the new version, is based on all the reactive stack. So they are using intensively the reactive stack in order to do routing from HTTP requests. And the other thing that I have in the Gateway project that you can, of course, go and take a look in GitHub is these dependencies, the Spring Cloud Kubernetes Discovery and Spring Cloud Kubernetes Config. This will allow the gateway to automatically register new services that are deployed inside Kubernetes and create a new route for the services, right? So every time that you deploy a service that matches with a label, that it's called S1P or something like that, it will automatically pick where that service is living, and it will automatically register it in the gateway as a path, right? So you can then use the gateway to access to all your services. So your consumers doesn't need to know 20 different paths or 20 different URLs. They just need to know one single entry point, and this is doing that automatically. And it's also using config just to make sure that, if a new service is added, we are just keep watching on those services. The code for this is nothing. So I have just a, Spring Boot application with the Spring Cloud Gateway dependency. And now in the Spring 5 and Spring Boot 2, just need to enable the discovery client so it knows where to look for these services. In the past, just to mention this again, the idea of abstractions, in the past you use the same annotation in order to register stuff into Eureka. That doesn't change in your application. The only thing that it changes is the dependencies that you add. And then some bootstrap configuration just for the polling, just for checking every time that the services are refreshed. And then some more configuration here, which is kind of like not important, but how to get the references and which services do we want to automatically register in the gateway, right? So this is just a filter on how we are doing discovery. Again, all the discovery here happens on the background. Like the gateway already had that concept built in, the idea of I want to find services. Please tell me from where, what's the source that I need to use in order to find the services. That means that, again, you just rely on the interfaces, and the gateway will do all that magic for you. It's not the same when you're building an application and you want to do discovery with your own domain logic, right? And this is the case of the concept service, which is pretty similar. So it has, again, nothing completely weird. It's like we are just using web flags and web and actuator, plus these Spring Cloud Kubernetes libraries in order to do the automatic discovery. I can go into the code. You can take a look at this, but again, I'm using the discovery client there in order to do automatic discovery of services, and you do this in a Java way, which basically is discovery client gets services. You will get the services, then you can just point to the services, nothing weird there, and then you can use the web client or the REST template in order to do HTTP request to that, right? So basically, this is doing this matching between labels and the name of the services and the type of the service in order to say, when you ask for a concert, if you want to know the tickets for that concert, just go to the other service, do the request, and then aggregate the response. I need to have 2 minutes left. That means that I will probably run out of time. And this is not, maybe it is, but this is not updated. No, it's not finishing. Something is failing there. All right. In theory, let's see where we are. So this is doing the deployment. Oh, no. What's going on? Oh, okay, so this is waiting. So basically what's going on is that it ran through all the pipelines. So that means that if I go here to Nexus and search for GeeCON, right, that was the group ID for that. It's there. So I have the jar in there. And if I go to the charts, which was the kind of like the last step, I have the chart in there. Now what happens, as I mentioned before, the promotion is basically sending a pull request to a repository, the staging environment where this service needs to be deployed. And that staging environment is also here in my GitHub repository. Again, it's a GitOps approach, and it will look into that repository and merge that. So that's my environment that has the same name of my cluster. And I can see that there is a pull request that it's still pending to be merged. And that's what the pipeline is waiting for. So it's analyzing that pull request can be merged into master. And as soon as that pull request gets merged into master, it's going to apply that change into the environment, which basically will include a new instance of that service. Have 46 seconds, and probably all not that things will happen. There is a conflict there, and that's why the pull request cannot be merged. I think that I can merge it, but it's not going to be done in time. Yeah, that's because I was testing on that before. Damn it. What is that? So that one, I think that's it. This is what usually happens when you're testing tons of times to deploy different things, and then you get some conflicts in there. I guess that what I can do now as well, where is it? Come on. I can merge that pull request again, and this will trigger the pipeline. Yeah, that's it. Timeout. But that will trigger the pipeline. One more thing that I will show before I go is that you can definitely query those services, right? So you can query those services and get the answers for those, right? So you have a console already created. It's not decorated because the tickets are not available, even though I have a service for that concert, and I can just query the concert by ID, and the service will be decorated there, and it's getting and aggregating the information from these two services. This is pretty much what you're going to do when you're doing REST-to-REST interactions between services, and these are kind of like the tools that you will need to use in order to make sure that you make this reliable. In general, you also need to evaluate messaging approaches. So that's pretty much what I have for today. You can take a picture on this because I will not even go through this. This is all the other things that go beyond Kubernetes, and these are the things that you also need to evaluate. But this takes a lot of time. So you need another presentation for each of these topics. So thank you very much. If you have questions, because I wonder that you will have, please grab me out and we can have a long conversations about these topics. So thank you, guys.